Ever wondered why honey flows slower than water? Or why a small pebble sinks faster in water than a larger one? It's all because of a fascinating branch of physics called fluid mechanics. Today, we're going to dive deep into this subject, exploring the concepts of viscosity, Stokes Law, the equation of continuity, and Bernoulli's theorem. Picture honey and water. Honey moves sluggishly, resisting motion more than water does. This resistance is what we call viscosity. It's like the fluid molecules are tiny interconnected balls. The stickier they are to each other, the higher the viscosity and the slower the fluid flows. For instance, when you pour syrup onto your pancakes, you see its high viscosity in action. It oozes slowly, forming strings due to the strong resistance between its molecules. On the other hand, water flows readily as it has a lower viscosity. Next up, Stokes' law. This law explains the drag force that acts on a small sphere as it moves through a viscous fluid. Picture tossing a ball into honey and then into water. The honey, with its higher viscosity, creates a larger drag force, slowing the ball down quicker than the water does. The equation of continuity is another important principle. It states that in an incompressible fluid flow, the mass entering any section of a pipe must be equal to the mass leaving it in the same time period. A good example is squeezing toothpaste from a tube. The amount of paste flowing out one end matches the amount entering from the other end. Finally, let's talk about Bernoulli's theorem. This principle shows the relationship between pressure, velocity, and height in a flowing fluid. As a fluid's speed increases, its pressure decreases, and vice versa. Think about air flowing over an airplane wing. The faster moving air above the curved wing creates lower pressure, generating a lift force that keeps the plane in the air. In summary, fluid mechanics explains how and why fluids behave the way they do. Viscosity measures a fluid's resistance to flow. Stokes' law describes the drag force on a sphere moving in a viscous fluid. The equation of continuity ensures the mass flow in a pipe remains constant, and Bernoulli's theorem relates the pressure, velocity, and height in a flowing fluid. These concepts are the backbone of many phenomena we observe daily. But remember, these are simplified explanations. The world of fluid mechanics is deep and wide, filled with fascinating principles waiting to be explored. So, keep those questions coming and continue the journey into the amazing world. Ever wondered why honey flows slower than water?